All right, this is 8th grades, 8.2.2, and we are talking about exponents still and how we can write them in simpler form. So let's look at the first problem. So it says we're going to rewrite expressions using exponents like we have been. So let's look at 859. And it says rewrite each expression below in a simpler form. So part A says 10 to the second. Let me make this bigger because it's not very big. There we go. 10 to the second times x to the third times 10 times y. So if I want to make this into a simpler form, I have to look at my bases, see what I can, see what exponents I can add to make it not as long. So here we go, let's see. I see a 10 squared and I see a 10. So that's kind of like an imaginary 10 to the first. So if I have a 10 to the second, 10 to the first, I know I can add those because if we're multiplying, say you have a 10 squared times 10 to the first, you can add the exponents. Okay, so let's add the exponents and we're left with 10 to the third, so those are done. So then we're left with x to the third and then y. So that's 10 to the third times x to the third times y, and that's actually as simple as it gets. Can't simplify it any more than that. Sorry, the phone's ringing in the back. Okay, next one is 20 to the third power times 20 to the 8th power. Same idea. If you are multiplying the same base, those exponents you can add together. So 20, we're going to be left with 20, 3 plus 8 is 11. So 20 to the 11th power. All right, part C is a little bit more involved. You got a little bit more going on here for part C. And it says x squared, I'm going to read off my paper, x squared, y squared, z squared times, but everything's timesed, z to the third times z to the fifth, x to the third, sorry. Okay, so now I have to look at, well, where are my like bases? So I have an x here and I have an x here. So let's look at their exponents, 2 and 3. 2 plus 3 gives us 5. So x to the fifth, done with that one. Let's see the y's. I only see y squared, nothing else, so that stays the same. Now let's look at our z's. So this is a z, not a 2. Z squared times z to the 5th power, 2 plus 5 is 7. So that would be our simplified form. Okay, 8-60. So that's 8-59, we're going to 8-60. Aaron wants to rewrite the expression 5 squared times x squared times 5 to the 4th times x to the 3rd in simpler form. She started by expanding the expression like this, and then it shows 5 times 5 plus x times x plus 5 times 5 times 5 times 5 plus x times x times x. And then she wrote 25, because she simplified that to 25, plus x squared plus, this whole thing is 625, plus x to the third. It says, do you agree with her work so far? And if you don't agree, write her a note explaining how to correct her work and find the correct simplification. So I'm looking at it and I don't agree based on the fact that she added in these plus signs for some reason when the whole thing is multiplied no matter what. If anything's like right next to something without any symbol, it's always being multiplied. So everything's being multiplied. So she needs to multiply all the terms, not add them. So then I came up with, if she multiplied all of them, she would get 5 to the second times 5 to the fourth. We keep that 5 and add the exponent, so it would be 5 to the sixth. And then it would be x to the 2 plus 3 fifth. And that would be, if you want to do 5 to the 6th in your calculator, you can, and that comes out to 15,625 x to the 5th power. Alright, so that was 8-60. Be careful with your symbols that you use. I think we are going on to the little resource page, the table, because we're coming into a new concept here about how to factor these types of problems. So I'm actually going to, I'll write it. So this is 8-61. I'm going to try and quickly do this. We've got original form. We've got factored form. I'm just going to put factored. And the other one is simplified form. So the first one it shows, and it shows this one for you, it looks like this. 5 squared raised to the 5th power. And then it has 5 times 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 5. So then simplified, I would count up my 5s, and I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it would be 5 to the 10th. So now, looking at that pattern, it wants you to fill out the rest of the table with the following expressions. So 2 squared to the 4th power. Okay, so we got to write that out in factor form. So this just means that I am going to take 2 squared and make 4. Alright, unfortunately I got cut off there and I filmed the rest of the lesson, so now I'm going to go back to where it cut off and continue. Okay, so we were on this row of the chart. So I'm going to look at my 2 squared to the 4th power, and the same pattern as the last expression, I'm going to make 4 groups of 2 squared, which is 2 times 2. I'm going to make 4 groups of these. I don't know why I write my 2's like that, but oh well. Alright, so there it is factored. Now let's figure out how many 2's do we have total. 2, 4, 6, 8. So we have 2 to the 8th. Our next one says 3 to the 7th to the 2nd power. So I'm going to make 2 groups of 3 to the 7th, which is 3 times 3 times 3 times 3 times 3 times 3 times 3. 1, 2, 3, 4, 5, 6, 7. Let's get one more. You might already see the pattern already of how to simplify these. So I'm going to count my 3's. I know there's 7 here, there's 7 here. 7 plus 7, 14. 3 to the 14th. Alright, now x to the 3rd raised to the 5th power. We're using a variable this time, but same idea. We're going to make 5 groups of x times x times x, because that's x to the 3rd. So x times x times x, x times x times x, x times x times x. That's 3 groups. We need 2 more. There's 4 groups, and here's 5 groups. So if I counted up all my x's, I'd have 3, 6, 9, 12, 15. So x to the 15th. Last expression is x to the 3rd times y to the 2nd raised to the 2nd power. So everything inside of the parentheses is going to be affected by the 2. We're going to make 2 groups of this whole expression, but factored out. So let's make 2 groups of x times 3 first, or x to the 3rd, sorry. So x to the 3rd, that's 1. Let's make 1 more. So that's 2 groups of x to the 3rd. Let's make 2 groups of y to the 2nd. So there's 1 group. Here's the second group. Okay, now if we count up our x's, we have 6 of them. So x to the 6th. We have 4 y's, so y to the 4th. So now it says for part A to describe the pattern. So there is a nice pattern going on here that makes it simpler than having to factor it all out. I'm noticing that every time there's an exponent with a base being raised to an exponent, you multiply. 2 times 5 gives us 10. 2 times 4 gives us 8. 7 times 2, 14. 3 times 5 is 15. 3 times 2 is 6. 2 times 2 is 4. So that is the pattern. The pattern I think I wrote out is when an exponent is being raised to a power, multiply the exponents together. So that's the pattern. So now for part B, it wants us to look at two different, actually it wants us to look at this, 20 to the 3rd raised to the 8th power. And it says to visualize that. It doesn't tell you to actually do it, just visualize it. And I'm visualizing, well, I'd have 8 groups of 20 to the 3rd power, which is 20 times 20 times 20. So I'd write that 8 times. So it says what's being multiplied? 20 times 20 times 20 is being multiplied, which is also the base. So they're going to call that your base. How many times is it multiplied? It's multiplied 8 times. So I'm not going to write it all out, but just visualize another group here, here, until we get to 8 groups total. I'm going to say 8 groups of that. So now it says, use the expression you visualized to help you rewrite it in simplified form. What's our trick that we just talked about for the pattern? Well, instead of writing it all out, we can look at the exponent and the exponent that is being raised, and we multiply them. So keep the base and multiply your exponents. You get 8 times 3 is 24. So 20 to the 24th power would be the simplified version of that. All right, 862. Says, in problem 859, you simplify the expression 20 to the 3rd times 20 to the 8th. So it's going to ask us, compare the factored form you wrote for this one to the expression we just did in the last problem, which was 20 to the 3rd times 8, or to the 8th power, sorry. So for the first problem, we came up with 20 to the 11th power here because we added the exponents. So now this one is going to be different because we're going to multiply the exponents. So this is 20 to the 24th power. How are the two expressions different? Well, in this one, we have the base with the exponent times by the same base with a different exponent. So we know we're going to add the exponents together to get our simplified form. For this one, we have a base with an exponent inside parentheses being raised to a different power. So we're going to multiply the exponents. So that is the difference between those. All right, the last problem says Heidi's trying to rewrite the two expressions below. So 2x in parentheses to the 3rd and 2x to the 3rd. It says, are these two ways of writing the same thing or do they mean something different, she wondered. Okay, so we're going to rewrite for part A, rewrite 2x to the 3rd by expanding and then simplifying. So this one. So let's expand this one. We know everything inside the parentheses is going to be raised to the 3rd power. So you can do this a number of ways. I'm going to do it like this. 2x times 2x times 2x. And then if we simplified that, we would get 2 times 2 times 2, which is 8. And then x to the 3rd power. So that's the simplified version of this. What part is being raised to the 3rd power? We're raising everything inside of the parentheses to the third power. So if you've got stuff inside the parentheses, just like distributive property, we're going to distribute that exponent to everything inside the parentheses. All right, part B says Heidi thinks that this one is the same as 2 times x to the third. Show that she's correct by expanding it. Okay, so we're going to expand this. Let's see, 2 times x times x times x. And that's the same as this because that 2 is not attached to the 3. The 3 is only attached to that x. So the x is the only thing being raised to the third power. So that is 2x to the third, which matches that. So now it's asking for part C to actually write it out. Are 2x to the third and 2x to the third equivalent? Why or why not? And it looks like they're not equivalent, and they're not, because the first one has parentheses, and everything inside the parentheses is being raised to the third power, which includes that 2. So it comes out to 8x to the third. In this expression, you don't have any parentheses, but you have 2 times an x to the third. So that x is the only thing that the exponent is affecting in that expression. So no, they are not the same. All right, and that is the end of this lesson.